Hi, good evening, and welcome to my daily live session on various topics from my toolkit for execution excellence. My name is Dinakar. I'm the founder of Samutana and the inventor of DoHow, a methodology for driving people and teams to achieve challenging goals and amazing outcomes. And during that entire journey of achieving these challenging goals and amazing outcomes, getting people to acquire leadership and management skills. That's the whole innovation which I'm talking about, wherein we drive people to achieve goals and thereby get them to acquire leadership and management skills. Leadership being all about people for doing the right thing, and management being all about systems for doing the thing right. One is effectiveness, the other one is efficiency, and we basically get people to acquire these skills, and in the process of acquiring these skills they achieve amazing outcomes and challenging goals. That's the core value proposition which I've been delivering in the last 8 years along with my team. And if you want to know more about what we do, please do visit dinakarmurthy.com or write an email to me. Dinakar@samutana.com is my email address. So with that very brief introduction, let me directly jump into today's topic, which is the application of decision analysis. Decision analysis is a methodology as part of the Kepner and Trego problem solving tools, where there are three tools I had mentioned. One is the problem analysis, decision analysis, and potential problem analysis. These are the various three tools in this methodology. And I yesterday explained in detail as to what decision analysis is all about, how it is done. And today I will try to talk about the application of these tools, the decision analysis, where it can be applied. So to give you a very quick recap, the decision analysis is all about identifying the factors which influence the decision, factors which are important for the decision making, basically the needs and expectations of all the stakeholders involved, and then classifying them into must and want factors, and then defining weights for the want criteria, and describing how each of the alternate options you have got for a decision supports each of these want criteria and the must criteria, or the must factors and the want factors, and then to give a score between 0 to 10, and after that calculate the weighted score and the total weighted score, and based on that, whichever alternate gets the maximum total weighted score and also is fulfilling the must factor would be selected as the most appropriate, most optimum decision to be made, which then will secure the buy-in automatically because everybody is involved in the decision making. So that's what I'm going to be talking about today. The two areas where it can be applied is in problem solving and in stable progress. When I say problem solving, it's about not the solving the problem, but once the problem is solved, then after that generally one has to select the corrective action or the preventive action. The corrective action could be investment to be done, in which case there could be multiple vendors who would be qualified for doing this investment, or it could be something to do with selecting a different process. There could be multiple options there, again to compare each option and then select the best option. And similarly, in the case of stable progress, it's about continual improvement during the entire journey of a cruising phase of a company, where basically the idea is to continuously sustain the existing performance and continuously keep improving the performance. And to do that, again, a lot of improvements have to be done, and thereby the weighted score methodology of Kepner and Trego decision analysis is the most optimum tool I know of, which involves everybody in the organization, and then that's the most reliable one, which is very systematic, and also you can trace back the decision. So these are the two areas where it can be applied. So let me talk about one example which from my life I felt was one of the toughest decisions to make, and then we could use this to really get all the people on board. I go back to my time in Germany, where I was involved in technology development. So technology development meant that we need to really look at the various technologies available, try to understand which is the better one, and then after that partner with somebody and get the technology developed. Now we had an application there where we had to measure a particular component. So this was about measurement system for a particular component, and that measurement system would then serve as the base platform for various other applications to come in the future. Then, if I remember right, we bought quite a lot of machines from this vendor using that technology. And later, I'm sure they're also marketing today to the third parties, because our agreement those days was that they could sell it only to Bosch for about 1.5 years, and after that they could sell it to any other party who is interested in that particular technology. So that was the basic context of what we are talking about. This was for a new product, and we had quotations from multiple vendors. Now in Germany, as you see everywhere, there is this not invented here syndrome, which is not surprising. In Germany, we had even today there must be still three, shall I say, quite strong plants, and each one of them were called as the lead plants for their own products. And each plant had their own preferred vendors for various reasons, ABC. It may not be anything so technically, we may not be able to justify, but then each one had their own preference. But we wanted to get a common platform which is acceptable to all the three parties. That is where the Kepner and Trego decision-making matrix came into our help. This was to really select between multiple vendors who wanted to partner with us for developing the technology to measure that component. And one was a German vendor, the other one was a European, was an American vendor, and one more was also a German vendor. So two German vendors and one American vendor. In those days, we had just then started, I'm not sure whether it is still active or not, what we called as a concept competition. That means even before we really finalize, because when you're buying a machine, normally what the machine tool manufacturers do is they sit with the manufacturing engineer and detail out in such a way that they are the only fellows who can meet that specification, so that no other company can even quote. That's the trick which many people play, and even today it is quite popular. Many vendors sit with the customers and detail out the specifications itself, so that it suits them, so that the other companies cannot compete in that space at all. So to avoid that, we had come up with a concept called as with a process called as concept competition. The idea was that you give a particular challenge to a vendor and tell him that, look, you are free to choose whatever you want to do, but tell us how you are going to do. We are not going to give you any details, and this is the cost we want to achieve. Cost per piece is X, and then the total capex which we can spend, our budget is Y. And with that basic criteria, and let us say there could be a target cycle time or whatever, and then based on that you give a concept. You don't need to give the entire detailed process, but then give the concept as to how you're going to do. And this concept has to be modular, because we should be able to shift over to a different platform and different product at any given point of time. It cannot be only done for one product. So based on that, the companies had quoted, all the three companies had quoted, and then there were multiple agencies there. The technical experts from all the three plants. When I say experts, they are really experts. They're people who have spent their entire life getting used to one technology. It's like somebody being comfortable with Windows, and somebody else being comfortable with Mac, or somebody being comfortable with an Android phone, somebody being comfortable with an Apple phone, or things of that kind. So where you can't really, what should I say, convince them that Apple is better than Android for the Android fellow, or for the Apple fellow to convince that Android is better than Apple. That doesn't really work out at all, because they have got their mind and they have made it up. Or maybe somebody who's driving his entire life a BMW, and then there's somebody who's driving a Mercedes, and these two you cannot pitch against each other, because he knows that BMW is BMW and Mercedes is Mercedes. So there's no point in justifying. And such was the strong conviction of each of these parties from the three different plants. Each one have got their own way of making it, their own way of measuring it. So each one had their own ideas. Then there was the central department, which again had, I'm talking about experts in each of these areas, because we are talking about measuring something which was in the range of 0.1 or 0.05 microns. For you to get an idea, just to get an idea for those of you who are not in the technology world, 150, 120 microns would be the size of the hair. My hair may be a little thinner, 80 microns, 90 microns possibly, but normal hair is about 120 to 140 microns. So if I'm talking about 0.05 microns, it means that I take a hair and then split it along the length 150 times, and that further 20 times, and that's the dimension which I have to measure. You just get an idea. So this is basically quite common in very high precision manufacturing in the automotive sector, and also in the lithography sector, where you are doing machines for making chips. And there again, it's really mind-boggling that the tolerances and the specifications there run into 1/10 of the wavelength of light. It's not about nanometer, much lesser than nanometer. Because if you do a nano chip cannot have variations in terms of nanometers. It should be 1/100th or 1/10th of a nanometer. So that's the dimension that we are talking about. We wanted to measure something like that. So it's really high tech, and we wanted to measure it very fast. So again, next challenge, speed is a challenge. Then the third challenge was we wanted to get the entire geometry of a surface. And for those of you who are in mechanical engineering, if you measure a surface, if you have to get the entire dimensional physical dimension of between two surfaces, you can use a vernier caliper, or maybe a very high-end equipment could be some kind of a comparator with pneumatic LVDT, linear variable differential transformer. LVDT is what it is called as, the technology. Or you could use some other probe, etc., which can be used for measuring the dimensional distance between the two surfaces. If it is to measure the entire geometry of that surface, let us say I want to measure the entire cylinder, then you need to use a form machine. It's called as a form tester, wherein the entire surface gets profiled using a probe, and then that gets later converted into a 3D image, and then you get the entire surface. You have multiple points collected there, and then form the entire surface. Something like that we wanted. So technology-wise, it was very challenging, and each one with a different background. So the 4 plants, and then there is a central department, and then of course there is central purchasing. Apart from that, because the purchasing guy wants the lowest cash outflow for the company. So all these people were in one group, and the purchasing guy was moderate. I was there as a kind of a, what should I say, a project manager or a program manager, because I had the budget. I was responsible for managing all such projects in Bosch at that time. We had a budget of about 30 million euros, quite a good amount. 30 million euros of revenue expenses, because these were all not capital expenses. There are 2 types of expenses in any company. Capex is where you buy in equipment, and revenue expense is something which you buy and then it is burnt in the same area. So there's no concept of depreciating that revenue expense. And my budget was about 30 million euros, which would be how much? 30 into 8, 3 into 8 is 240, 2000, 2.4 billion, which is 2.4 billion, 2 followed by 8 zeros, 200 crores. 200 crores was my budget, just in the Indian terms. 200 crores was my budget, which is the revenue budget, not the capital budget, which means that money is spent in that year. That's it. End of the story, and after that it's gone. So that was my role. I had to really define where do we spend that money, because all these developments involved a lot of development cost, and that was being funded from my budget. That is what I was responsible for. So I was there as the program manager and all the others experts in the room. And then we would go through finding out which are all the want and the must criteria. And that was really fantastic. Must criteria, maybe the cycle time had to be met, otherwise we could not get the production out. And the must criteria was that the minimum accuracies had to be met, because otherwise we could not really do anything. Then the want criteria. We must have spent about 2 to 3 days, full days, okay, to really discussing about the want and what is the weightage of the want. From an international perspective, the other challenge which I had was to make it a standard for the entire world. That means whatever we bought there had to be then used in India, Brazil, Japan, Korea, Turkey, US, wherever it is, entire Europe. So it had to be something which can be used in the entire world, and the vendor had to be present in the entire world. So this were the other challenges which I had, to make sure that it is standardized. Why is it required to be standardized? Because if you standardize it, then the cost comes down, number one. And number two, we could get what is called a global release. That means a particular product could be manufactured in any part of the world and then shipped to the customer without any additional approvals. That means there is no need for any approvals if we shift the location from plant A to plant B. And that flexibility is something mandatory for ensuring that you are able to balance out the global capacities. And that's again another thing which is possibly a little specific in manufacturing. So global capacities to be balanced, to make sure that the factories don't have any imbalance in load. We need to be really shifting the components from one location to another location, or the demand has to be shifted so that the production is done in various locations. It gets balanced out. For that, the global release is something which is very nice to be having a flexibility of sending the customer a particular product from any plant of ours, wherever in the world. To do that, we had to get identical technologies, identical machines. So that was the other driver for going in for standardization. 2 days, we only debated on the weights. And after that, we started talking about the specifics of each of the alternates. And there, whoever who was basically supporting that alternate could basically describe and explain why that alternate is going to support each of the criteria, each of the factor. And that maybe took another 1 or 2 days of homework, because they did outside, and after that we came back to discuss. And in about let us say 2 additional days, all of us could come to an agreement of choosing one particular vendor who was not acceptable to the plant with those experts with 35 years of experience in using something which was not this solution. Similarly, for the central department who had a different idea, the purchasing department who had a different idea. So what I'm trying to say is this particular methodology could get everybody on the same page, though they had conflicts, in a very, very professional, objective manner. And later the decision got implemented, and of course the execution was seamless, because we had the buy-in of everybody. Everybody started working towards one goal. And that kind of a magic can be created by Kepner and Trigo. Decision analysis is the key role of a leader. And so that's one example which I wanted to say. So wherever there is a conflict amongst parties, and you need to really come to a decision wherein everybody have to buy into that. One is to bulldoze that. You can really say that, look, this is the way it is, it has to be done. But that strategy will not create inspiration. That strategy will not create commitment. It can only create kind of a, yeah, okay, I'm going to do it, but not really so much excited. And that is not really good for creating excellence in any organization. So that way this tool is very useful, and it was very useful to me. So with that, I come to the end of today's live session. So thanks a lot for watching. For those of you in India, have a nice evening. For those of you outside India, have a great day ahead. See you tomorrow, more or less at the same time. Sorry, I got delayed today. I had to visit somebody and got delayed. Tomorrow, I hope to start at 8:30. And tomorrow, my topic would be the negatives and the cons of Kepner and Trigo decision analysis. Thanks a lot, and goodbye. See you tomorrow.